My name is McClusky. I'm a position, navigation and timing specialist based at the ANU, Research School of Earth Sciences. And I'm also at the moment working with Geoscience Australia as a consultant on the National Positioning Infrastructure Capability Program. I'm just going to give you a very quick intro into the current state of space-based positioning and navigation technologies available. So the world of positioning, navigation and timing, also known as P&T, is evolving pretty quickly. A decade ago, we had 1 or 1.5 global navigation systems, satellite constellations on orbit and operational. GPS is the system that most people recognize and have had access to through apps like Google Maps, etc. But today we have 5 operational GNSS systems or constellations, and they're all operated by different countries or groups of countries. Australia is a big beneficiary of this expansion in GNSS constellations. The movie playing at the moment is basically showing you the visibility of GNSS satellites across Australia, in fact, across the world. What you'll notice is that Australia is actually in the hotspot, in the red zone, where from these multi-GNSS systems, we're able to have visible at any time greater than 30 satellites in view. What this means is that we have potentially better or at least more reliable positioning and navigation, particularly in situations where sky visibility might be poor. So what changes for positioning and navigation in this new era of multi-GNSS? This cartoon you're looking at now shows how we've traditionally positioned ourselves using GPS observations. The positioning data is received directly from GPS satellites by devices containing an embedded receiver, and this mode of positioning is able to provide instantaneous positioning with an accuracy of somewhere on the order of less than 5 to 10 meters. The addition of multiple GNSS constellations to this system has meant that we've got more redundancy now and probably more reliable positioning, but this hasn't really provided much of an improvement in positioning accuracy or precision. So the major limitations to this type of positioning are things like the atmosphere, errors in clocks and satellite orbits, which mean that we can't really get below that at least 2 to 3 meter precision for positioning using that mode of just taking the direct signals. So we can improve positioning precision by correcting for these errors, the atmosphere, the clocks and the orbits. In countries like the USA and other European countries, satellite-based augmentation has been used to deliver these corrections for quite some time and provided basically sub-meter or meter level positioning for about the last decade. SBAS uses basically a geostationary satellite system to deliver these corrections, and SBAS has been most widely adopted in the aviation sector for navigation of aircraft. In Australia currently, we are preparing to build and deploy a next generation SBAS system, which we are hoping will deliver something on the order of 10 to 20 centimeter level positioning through this mode. In addition to SBAS, we're also building a system to deliver these corrections via a mobile internet system. So any positioning device with mobile connectivity will have, we hope through the system, the capability to position themselves with a precision at about 3 centimeters. And this is all without running your own local base station to do it. So essentially, this is what we're aiming for by the end of the National Positioning Infrastructure Capability Project. We're aiming to have PPP, precise point positioning, real-time kinematic, delivering 3 centimeter level type precisions anywhere in Australia where we have mobile internet coverage, and across the Australian continent and maritime zones where SBAS signal can be received. In fact, this stretches all the way out to New Zealand, who are involved in this project. We are hoping to be able to deliver 10 centimeter accuracy anytime positioning. So this is essentially the vision that we have is for an integrated national positioning capability to accelerate the adoption and development of location-based technology applications across Australia, of which the agriculture sector is a big part. So how is this all being funded? Basically, the NPIC SBAS project was appropriated in the 2018-19 Australian government federal budget where $225 million was allocated over 4 years. And this was to deliver those two systems, which I've just talked about, the SBAS system, with $161 million budget, and this $64 million for upgrading infrastructure and delivering the internet-based correction system. So just a quick summary of what's going to be delivered by this system. We're getting an improved ground station network, which will allow us to calculate these corrections, which we're going to deliver by satellite and the internet. All that data will be publicly accessible, as well as data that's currently collected by state and territory and private sector data providers. We're developing a toolkit for analysing this data and generating the corrections, and then we're also building a system to actually deliver these corrections via SBAS and PPP-RTK. If you're interested in looking into this more, Geoscience Australia and Frontier SI ran quite a significant testbed study before they embarked on this project, and they looked at they basically started broadcasting a test signal on a geostationary satellite that was positioned over Australia, and they tried out several different next generation SBAS technologies, not just delivering L1 single frequency SBAS corrections, but also dual frequency and this PPP-RTK correction, which gets you down to a much higher precision. But anyway, there are 27 projects across a number of different sectors, including the agriculture sector, in this study. If you're interested in looking into what the projections of the benefit to Australia were from those case studies, you can look it up on the Frontier SI webpage, and I've just put a little summary of what the perceived benefits over the next 10 years were that were arrived at by the Ernst & Young.
That's great, Simon. Thank you very much. Great to see sort of the developments there and the sort of level of precision that's being developed.